All right, today's lesson is exploring the rate of change, or the slope. I should say we're revisiting this topic. So we've already looked at finding the slope or rate of change from a table of values. We've done that already. So we'll see that again one more time. And then we've also looked at the graph of the relationship and how we find the slope by drawing little triangles. So we've done those two already. So this is going to focus on by calculation. Okay, so this little formula we're going to develop, and you're going to see that we can calculate the slope using that. The steepness of the slope or the rate of change, just to keep in mind, a positive slope goes up from left to right, so this is considered positive, and then negative slopes go down from left to right. So, oops, that's negative. So just as if you would read a book, that's the order or the direction we read. So positive up to left and right, negative down from left and right. Okay, we've looked at this definition of rise over run for our slope. So rise, go with y's. You run along the horizontal or the x's. Something to keep in mind. So change in y values, change in x values. So little deltas just mean change. Okay, so complete the table values for the linear relationship below, then we'll plot the graph, we'll determine the slope and y-intercept. So this should be review. So here is our equation. So if I substitute in values, so if I put x equals 0 into that, y is going to be 3 times 0 minus 4, which should be negative 4. Go to the next one, y equals 3 times 1 minus 4, which is negative 1. And then normally if you do 3 points, you should have a bit of an idea of what the pattern is. So 3 times 2 is 6, minus 4 is 2, and if you come over here you can start to see these guys are all changing by positive 3. So our next entries would be 5 and 8. It's always good to do at least 3 entries just in case you make a boo-boo. So keep that as a bit of a habit. So we can see our first difference is 3 for all of these. We've also talked about finding the slope from our table. You can see this side all changes by 1. So from our table, our slope or multiplier is 3 over 1. That's rise over run. Okay, if we were to graph this really quickly, 0, 1, 2, 3, 4, and then 1, negative 1. And you might be at this point in time starting to see a bit of a pattern in your graphing and how you can make these a little quicker. So if you look in between these points, there's a change of 1 in the x direction and a change of 3 in the y direction, and that matches up exactly with these guys. So it's like a little staircase, 1, 3, 1, 3, 1, 3, and you can take advantage of that and actually graph the line a lot quicker once you know the slope, because that pattern is going to be repeating. Okay, so if we look at a couple things here, we now have a slope of 3 over 1. We have a y-intercept of 0, negative 4. And none of that's a big surprise because we can, if I put a little placeholder in here, we know that the slope comes from the equation when it's in this particular format, and the y-intercept also comes from this equation, again, when it's in this format. And we're going to expand that in this unit. But that's a quick review of all the major concepts we've sort of covered so far. So let's look at determining the slope of the line for the following. So we have this point, these 2 points A and B at 1, 2, and 5, 10. So I've drawn those here. So what we would have done in the past is we would have just come in here and we would have counted squares. Each one of these squares is worth 1. That's why we can count them. If they're not worth 1, then we have to do some other things. So this has a run of 4 and a rise of 2, 4, 6, 8. So if you were to look here, the slope would be 8 over 4, and we want to get in the habit of reducing this. We want to make sure our slopes are small, or in lowest terms, so we should see that as 2 over 1. And again, if you went in here and you went, remember this is y and this is x, so if you went up 2 over 1, you land right on there. Up 2 over 1, you land right on the line. Okay, and that has to be true. You can't break those rules. It's important to use a ruler for these so you can validate all of those ideas. Okay, so now let's try this with a little slightly different idea in mind. I'm going to look at this right here. I'm going to say 0.1 values subtract 0.2 0.2 values. So this is 0.1 here, this is 0.2. So if I look at my x values, and I just take my 0.1, so I'm going to take 1 minus 5. I'm going to get a negative 4. I'm going to look at my y values, and I'm going to have 2 minus 10, and I'm going to get a negative 8. Now if I bring those two ideas together and I make my slope, okay, that's negative 8 over negative 4. Okay, so if you looked at this graph, what that means is I went down 8 because it's negative, and left or back 4. So this would be down 8, and this would be left 4. And if you simplify that though, negative divided by a negative is positive, 8 divided by 4 is 2, and oh my goodness, we get the exact same answer we got down here. Now I'm going to do this one other way, just for argument's sake. I'm going to do 0.2 values subtracting 0.1 values from them. So if I do the exact same thing, well, then I'm going to reverse the order. So now I'm going to do my x's first. It'll be 5 minus 1, and ooh, big surprise, there's the 4. And then y values, if I went 10 minus 2, there's the 8. And again, if I bring those both together with my rise over run, I get 2 over 1, which isn't really a big surprise because we knew the slope was already 2 over 1. So there's an idea there that we're going to build on and focus on. Eventually it's going to come out as a nice little formula. But let's just test one or two to make sure it works. So let's start here. Determine the slope of this line. We have points at 3, 6 and negative 3, negative 2. So now we have points on the other side of the axes. So we'll see if our theories work here for negative numbers. So if I make a little triangle here and I just count really quickly, because sometimes that's the easiest way to get these. 1, 2, 3, 4, 5, 6, 7, 8 is my rise. 1, 2, 3, 4, 5, 6 is my run. So my slope here is 8 over 6, and I want to have that in lowest terms, so that would be 4 over 3. Okay, so now let's go over and we'll try our 0.1. So let's look at our x values. So if I have 1 and I look at x's, so 3 minus negative 3. That's really important. Keep track of those signs. You get a 6. Y values, you have 6 minus negative 2. Again, there's those darn double negatives we have to be careful of. And if we organize this as rise over run, we get 8 over 6, which is exactly what we got over here. So no big surprise. And this turns into 4 over 3. Okay, so let's try it with 0.2. Just slide this down a little bit. Okay, so 0.2, there's my x values, and if we went negative 3 minus 3, there's the negative 6. Y values, that would be negative 2 minus 6, that becomes negative 8. And again, if we bring these down and rearrange them into slope formula, negative divided by a negative is a positive, and that becomes 4 over 3, just like we had in the other ones. Okay, so we'll do one more like that just to make sure. This one's going to be something a little different here. So the previous two, you notice we had positive slope. On this one we have negative slope. It's going down from left to right, so we're going to do a quick test. We'll check this out. Let's go back in here and we're going to draw our little triangle. Okay, so if we count 1, 2, 3, 4, 5, 6 in the rise direction, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now we have to make one little adjustment here. Okay, somehow this slope has to be negative. Okay, so I know the values are 6 and 9, but that's a positive slope. So what I'm going to say is if I start here at this dot, I went down 6 and right 9. Okay, so if I counted that, that would be a negative 6 over a positive 9. If I went the other direction, and I can do that as well, and see if yellow will show up, that would be going up 6, but then it would be going left or back 9, and I would still end up with 6 over, I'd still end up with a negative value, no matter how I do that. So I'm just going to backtrack and get rid of those because they're kind of in the way. This would reduce, of course, to negative 1 over 3. And if you do a quick test, if you go, did I do that right? Sorry, negative 2 over 3. That looks better. Okay, so if I go down 2 and right 3, I should end up on the line. Down 2, right 3, I should end up on the line. And that's a quick way to check your work. So let's go and try our subtraction. I'm pretty sure we're confident now this is going to work, but we'll just test it. So if I look at the x values, so 0.1, 3 minus -6, watch the double negatives, there's the 9. Y values 0 minus 6, there's that negative, so if we bring those together, there's -6/9, which we've already seen, and we know that reduces. If we go to purple, x value -6 minus 3, so there's -9 this time, of course, and then y values 6 minus 0, and that's 6. So if we write our slope for that one, that is 6 over -9, and we still get -2/3, which isn't a big surprise because it's the same question. So we come up with this really cool formula. So if you look at this, you'll notice that the y values, I've just subtracted those two, and if you noticed in the 3 previous examples, it didn't matter the order which term was 0.1 or which one was 0.2, it doesn't really make a difference. What you do have to do is make sure you're consistent, so that these guys here, notice those are both x2 and xy2, those are both 0.2 pieces of information. So you have to make sure the order in terms of 0.1 goes first all the time or 0.2 goes first all the time. Okay, you can't crisscross them, so that's really important. So we can expand our definition of slope from rise over run to delta y over delta x to now we have our formula. Okay, so now the hardest part for people is just putting the values in the correct location. That's it. That's all you have to really worry about. Okay, so let's try one. So let's do, okay, determine the slopes of the line segments of the following. So I have my formula. What a lot of people do that really helps, and I would strongly recommend it, is you can put little names over the top until you get to a point where you're really comfortable. Okay, so if I called A as my 0.1, I'm going to label this x1 and y1. Okay, if I call B my 0.2, I'm going to call that x2 and y2. Now all I have to do is put that information in the right location in the formula. That's it. If you can do that, then this is a breeze. Okay, so the y2 value is 5, the x2 value is 3. So please notice, they're over top of each other. They're not crisscross, they're not on the same line, they're over top of each other. That's really, really important. Okay, so now we're going to subtract from that y1, which is a 1, and then we're going to subtract from that x1, which is a -5. Okay, and I'm sorry I'm running out of room, so I'm going to just go this way. And I end up with 4 over 8, which simplifies down to be 1 over 2. Okay, and maybe if I'll slide this over here, and I'll just do the picture over here if we need to. If you have to, you can always do a graph, plot the 2 points, and then -5, 1, 2, 3, 4, 3, 4, 5, up 1. So there's a dot, and then 1, 2, 3, 1, 2, 3, 4, 5. Connect those. Okay, draw a little picture. Count them, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. You can see clearly it's positive slope because it's going up. So you would have 4 over 8 or 1/2. Okay, so you can do it with equation, you can do it with picture. They're both up to you. It does not matter. Okay, I'm going to clear that out for 1 second so I have enough room to do the next question. Okay, now the next question has a little bit of a trick in it, and it's not meant to be devious, but we need to be aware of it. So if I plot the point 6, 1, and I plot the point 6, -7, oops, 1, 2, 3, 4, 5, 6, 7, there it is. Those are my 2 points. And if I draw a line through those, oops, went too far, backtrack. Let's just go from there to there. Okay, so if we look at this, I can't draw a triangle here. So this one's really unique in that it's a vertical line and the run is 0. So if you tried to do this with your expression or your equation, And again, you can write the titles on here. Okay, so -7/6. This is the way I always do it. I always write them over top of each other quickly. Makes it a little easier. And now you end up with -8/0. Well, this is a unique case, and you can try this on your calculator. You can try it on any computer you want. You cannot divide a number by 0. This is what we call undefined. Okay, and an undefined case is the only case we really have to worry about. There's two, actually, I should say. Undefined is one. We'll look at a horizontal line in a minute. This is the only one that doesn't work on your calculator. Okay, so that's why you have to know the formula. You have to know how to draw these pictures so you can support your answers. It doesn't take much to see, though. If we were to draw a horizontal line, the rise on a horizontal line is 0. So the slope of a horizontal line is 0/1, which equals 0. Oops, I didn't grab that. Let's move that over. Okay, so there's only two special cases to really worry about when it comes to finding slopes. One is vertical line, okay, and one is horizontal line. Okay, so horizontal lines right here have a slope that's 0. Vertical lines have a slope that's undefined. Take a minute, write that down, put that somewhere, because that's one of those sneaky little questions that comes up and gets people when they're not expecting it. Okay, so find the slope between the following 2 points. If you want to pause it here and just try these, make sure you can punch the numbers in the right locations on your own, and then I'll do them really quickly. Okay, so let's give it a whirl here. So again, I am a little more comfortable. You may want to put all of these values above, just like that. So 10/5 -2 -1. So the top one becomes 8/4, which becomes 2/1. Okay, I'm going to run out of space here, so I'm going to do my best. And and again, we can switch the order. It doesn't matter in terms of which point goes first. Do watch out for those negative signs. So let me just double check my signs here. So 4/7, 9/-3. I'm going to run out of space, so I better move that down a little bit. And now we have -5/+10. So this becomes -1/2. Okay, and then lastly, we have 1/1 minus, so lots of negatives in this one. Got to be really careful. So this becomes 2 on top, 8 on the bottom, and I want to make sure I reduce. So the slope for part C is 1/4, so we're going up 1 and running 4. So this would go up 1 and run 4. So it's kind of a flatter line. Okay, and then we'll do one little word problem just to sort of get our heads in that space. John went for a bike ride and collected the following information from the odometer on his road bike. So first of all, is this a linear relation? So we do a quick check. These are all changing by 1 hour. That's really important. These is measured in hours. And these are all changing by 10 kilometers. And as soon as it's a word problem, you want to keep track of the units. So yes, this is a linear relationship because the first differences are constant. Okay, so we know it's linear. What is the fastest rate that John traveled? Now this is a key word. Anytime you see rate or per, those are indicator words that you want to find slope. And you gotta know that, okay? So what is the fastest rate? That immediately tells you find the slope. So the slope for this problem, because we have multiple strategies to do this, we could use our table of values. That would be the strategy I would use because it's quickest. It's right there in front of me. It's 10 kilometers every 1 hour. That isn't to say you couldn't use the formula we just developed. Take two different points and plug them into your formula. It will also work. And I'll do that super fast here just to prove the point. So if I take those two pieces of information, I would have 30/3 minus 10, and then 3/1, and that would equal 20/2, which would equal 10. Okay, and again, that's 10 kilometers per hour. Per hour. Cool? Okay, a couple questions to try on 278, and then there's also a little handout that goes with it. Thanks for tuning in.